Hello, welcome to our presentation. My name is Matthias Botiski. I am with secunet Security Networks, and together with my colleague Anja Strung from Cloud and Heat Technologies, we would like to present you how to secure your sensitive data in OpenStack infrastructures. To do this, we set up a new project called SecureStack. And before we dive deeper, let me show you the agenda for this presentation. First part, we will introduce ourselves and what's all about this project. Second point, we want to share with you our comprehension about secure cloud infrastructure, as this is the base for our project. Part 3 and Part 4 will go into some technical details, and Anja will show a demo as well. It won't be a live demo for time-saving reasons, and and the final steps are, or the final parts are, we will show you what we have for future plans for this project, and if we have some time, there will be a Q&A. Okay. The project we called SecureStack, and SecureStack is a joint venture between two German-based companies. One is secunet and the other one is Cloud and Heat. And SecureStack, it is our vision to build and provide the most secure OpenStack infrastructure. I know it's a very bold statement, but well, we're trying very hard to achieve this. And the first part of this project is company secunet, and secunet is a German-based company, and we provide high security and trustworthy products in the field like e-government and applied cryptography, business security and automotive security, and we are one of the main contributors to the StrongSwan project, which is the open source IPsec implementation. And we are the secure part in the SecureStack project. And the other part, the stack part, is the company Cloud and Heat, and Cloud and Heat is a public and private cloud provider of OpenStack-based and an OpenStack-based public and private cloud provider, and all the cloud solutions are based on their own server base, and they do some clever things with energy efficiency. And what they do in their data centers, they use the heat loss from the servers to heat houses, facilities, and even hotels. And they've been awarded multiple times for this concept. And the reason why we've created SecureStack, or this project, is when we talked with customers about cloud and security, they come up with special needs that are not implemented in OpenStack right now, especially security needs. And so that's the reason why we've created SecureStack. So in a nutshell, SecureStack extends OpenStack with security enhancements. When we've talked with our customers, mainly in the public sector, about cloud and security, they mostly come up with these points that need to be addressed and that they want to be solved. And that's the first thing is securing user data. So data has to be stored in a safe way and only accessible by the user. With SecureStack, we are trying to encrypt all the user data on block storage, and we also encrypt the images and sign the images with digital signature to retain the the second is key management by user. Users want to bring their own keys, and that means the cloud provider mustn't be involved at all in the key management or in the crypto management. The third is secure access to cloud. Users want a secure and trustworthy connections to their cloud environment, and with SecuStack we've managed this in a way that we build up a secure VPN connection into the cloud. The fourth is separation of projects. If you think cloud as a multi-tenant environment, then you need to separate those tenants, each from another. So this goes also to the data, and with SecuStack we provide a strong separation and encryption for each tenant, so they don't get interfere with other. And the fifth point is hardening and protection of OpenStack infrastructure. This is a broader, wider range of measurements we've taken, as this builds the foundation for all the other measurements for separation of projects, secure access, key management, and securing user data. Because we don't have too many times showing you what we've done so far, we've picked securing user data and key management, and we will show you what we've implemented so far in this area. So securing user data, these are the requirements we get from our customers, and these are mainly requirements in the volume block storage area. It's what they want is they want all their data fully encrypted. They want their image signed. The image needs to be encrypted, and all the additional block storage must be signed and or encrypted. And if we take a look at what OpenStack offers right now, we can clearly see some parts are missing. For example, image encryption, root volume encryption, and signature on additional block storage. And to show you what we've implemented so far, I hand over to Anya, and she will show you some more technical details.
Thank you, Matthias. To explain our concepts, we choose the simple example. It's a secure migration into the cloud. And we have Alice here. Alice has a business, and she uses a physical server to operate their business, and she wants to migrate that server into the cloud. She's supported by Bob. And the third entity in that scenario is Eve. Eve has physical access to the cloud server, to the cloud's hosts, and tries to tap data from Alice's physical server, which is migrated into the cloud. To run that scenario successfully, we need to perform 3 steps. The first step is that Bob has to create a secure image. And the secure image is encrypted and signed. The second step is that Alice creates a bootable volume out of that image. That means the encrypted image and the signed image has to be downloaded, the signature has to be checked, the image has to be decrypted, the content has to be copied in the volume, and the volume has to be encrypted. And the third step is that Alice creates a server and attaches the volume, which was created in the previous step, securely to that server. And I will focus on each step in more detail. I will explain how OpenStack does or perform these steps originally, and I will compare it to our SecuStack solution. Let's start with the first step, the creation of a secure image. Bob creates that image, and he uses the OpenStack client for that purpose. We have also the image service here and the key service. And what Bob already did, he created a local image out of the physical server, and he also created a signing key to sign the image and the appropriate certificate. And what he now has to do is he has to upload that certificate into the key manager, so that everybody who wants to check the signature of the image is able to download the certificate and do the checks. The next step is that Bob has to sign the image. This is not done by OpenStack client. Bob has to do it by himself. And when the image is signed, he can use the OpenStack image create command, this original OpenStack client command, to upload the image to the cloud. Because there's no encryption at all, Eve, who has access to the physical server, is able to read out the content of the image. The image is just a file in the storage backend of the image service of Glance. And when you have access to the physical host, you can read out the content of that file. Of course, normally only the cloud provider has access to the physical host, but imagine there's a bug in the image API, for example, or in the storage backend, or there's another way how an unauthorized person has access to the physical host, then the secrets in the image files are not secure anymore when you don't have any encryption. Let's compare that behavior with SQStack. We extended the OpenStack client so that he now does encryption and signing of the image. Bob created, therefore, a key and a symmetric key to encrypt the image. This is a green one, and the signing key for sure, and the certificate are already there. And Bob uploaded already the certificate into the key manager, in the key service. And now Bob uses an extended OpenStack image create command. This you can see here. We extended the OpenStack image create command with 2 additional parameters, -- secure, with a reference to the key to use to encrypt the image, and -- sign, with a reference to the key to sign the image, and also the UUID for the certificate used for image checking, for the signature check. And with this information, the OpenStack client starts the work. That means the OpenStack client encrypts the image, and we use AES 256 for that purpose. And the OpenStack also signs the encrypted image and uploads the image to the image service. And if now Eve tries to access the image file, reads out some information, she still gets data, but it's just garbage. There's no useful information because the data is encrypted. Let's have a look at the second step, the creation of a bootable volume. First of all, the behavior of OpenStack. We have the OpenStack client here, we have the volume service, we have the key service with a certificate to check the image signature, and we have the image service with a signed image in place. And now, Alice uses the OpenStack volume create command to create a volume. And what the volume service now does is, it creates an empty volume. It's, in our case, an LVM volume because we use LVM as storage backend. In the next step, the image is downloaded from the image service to the volume service, and the signature is checked. In the metadata of the image, there is a reference to the UUID of the certificate, which has to be used to check the image signature. And then the data from the image is copied into the volume. The image is in clear text, and the volume is in clear text. So Eve has 2 possibilities to read out secrets. In SQStack, there are 2 differences. First of all, the OpenStack client has the image key and the volume key. Both are symmetric keys, and they are on the client side. They are never stored in the cloud. So it's similar to the concept, bring your own key, that the client, the user, creates keys and can use these keys to encrypt his or her resources. The other difference is that we have the encrypted image in our image service. There is no clear text. We have to decrypt the image prior to the copying into the volume. So what happens now is we also extended the OpenStack volume create command with an additional parameter. This is -- secure. And with this parameter, we tell the volume service, OK, please create an encrypted volume for us. And this is what the volume service does. It creates an empty volume with a LUKS layer on top on it to have the encryption. And then the creation process stops. It stops because to copy the image, the keys for the volume and the image are requested. And we provide that keys in a second step. This is the provision step. So SecuStack has an additional command, this OpenStack volume provision command, with two parameters, -- secure, with a reference to the volume key, the key which is used to encrypt the volume, and -- secure source with a reference to the key that is used to decrypt the image. These passes are local passes on the client side. And what now happens is that the volume service downloads the image. It is encrypted and signed. And then, with the help of the keys from the client side, the image is decrypted and copied immediately into the volume which is encrypted. There's no clear text information at all. There is a second signature check prior to that copying process, which is not in OpenStack originally. We added it because we want to check if that image, which is temporarily stored on the volume service after the download process, was modified or not. The keys to decrypt the image and to encrypt the volumes are not transferred in clear text, but they are transferred end-to-end encrypted. Therefore, each volume service has a certificate for identification purpose. And this certificate contains a public key. The OpenStack client downloads that public key, encrypts the two keys, the green key for the image and the key for the volume, and transferred end-to-end encrypted to the volume service. The overall motivation for that is that we want to limit the knowledge of the keys to as less as entities as possible. And the minimum set is the owner of the key, which is Alice, and the target volume service. That means that volume service that actually hosts the volume. In an OpenStack infrastructure, there are several volume services. And it's a task of the scheduling process to identify that volume service that fits most. And we only want to send the key to that volume service that actually hosts the volume. We do not want to spread the key among our services in our entire OpenStack infrastructure. That's also the reason why we had to split the creation process. Because the scheduling is part of the creation. You do not know on which host your volume is placed on prior to the volume creation, just during the volume creation. That's why we splitted the creation process into a creation process, which does all the database entries, selects the volume host, and then places the volume, and then the creation process stops. We now have the knowledge which target host we use for our volume, and with this knowledge, we can send the key end-to-end encrypted to the appropriate volume host, so that we limit the knowledge of the keys to the minimum set. Now we have encrypted data, both the image and the volume are encrypted, so Eve is not able to read out any useful information. The final step in our scenario is the creation of a volume-backed server. And first of all, again, the behavior of OpenStack. Alice uses the OpenStack server create command to create a volume-backed server. And the volume, which is not encrypted in this case, is attached via libvirt to the server. When we use SecuStack, we have an encrypted volume. And we need the key to decrypt that volume and attach it to the server, because the server needs information in clear text to boot from it. And that's why we have, again, a two-step process. The first command is the OpenStack server create command, where the compute service is selected and the server is placed on the compute service, and then the creation process stops. And Alice has to trigger the or has to proceed the creation with a second command. This is a server spawn command. It is not included in OpenStack. It's a new command we introduced in ZQStack. And here is the same as in volume creation. In the volume creation, the compute service has a certificate with a public key in it, which is downloaded by the OpenStack client and used to encrypt the key for the volume and to send the volume key end-to-end encrypted to the compute service so that the compute service can encrypt the key, decrypt the key, and use it to attach the volume. As Matthias already mentioned, we prepared a demo, and I want to show now a demo for this entire scenario. What you see here is the beginning of the demo. We have printed out some information. You can see, for example, where the image is stored and the UUID of the certificate used to check the image signature. It's already uploaded in Barbican. You see the path to the key, which is used for signing. You see the path to the key used to encrypt the image and other useful information. And what we now do, we print out the certificate. You can see it's a certificate. It's already stored in Barbican. And now we print out the key used to encrypt the image. It's a private RSR key, nothing special. Now we create an unencrypted volume with the OpenStack original behavior. It's nothing special. It's just the normal OpenStack image create command. We repeat that step with a secure image. It's called demo secure. And here we use our new ZQStack command. We highlighted the new parameters, which is --secure and --sign. And with this information, the OpenStack client, as I already mentioned, encrypts the image and signs the image and uploads the image to the cloud. Here we ask for the password for the private key. And now we list the images which are stored in our cloud, and we see both the insecure image called demo and the secure image called demo_sec are both available and can be used. What we now do is we log into our image service. This is all in one setup for demonstration, so we realized the individual services as Docker container, and what we now do is we log into that Docker container for the image service and list out all information which are stored in the image directory. We list all files which are stored there. And what we can see is the first entry is a GPG symmetrically encrypted image. The images are stored in a file which has the same name like a UUID of that image. So we see this violet, blue, whatever color. This is the ID of the secure image, and you see that the secure image is a GPG symmetrically encrypted image and the other image not. What we now do is we print out the information of the image file. We do a simple strings command and grab for the string begin RSR private key to check is there any information, are there any keys in that file contained. And we do this first for the insecure image, and you can see there are a lot of private keys in there, which Eve can read out. And we do the same for the secure image, and you can see it's not able to grab any information. Now we create a volume. So the image is there, the image is encrypted, and we create now a volume of it. And we do both an unsecure and a secure volume. This is the key for the volume, which has to be encrypted, so it's a secure volume. And we create insecure volumes called demo. This is the normal OpenStack volume create command, nothing special. The volume is created, and we will repeat that command with encrypted volume. There's one thing we added to each resource in the OpenStack infrastructure. We added a special property called ZQStack, which identifies whether or not the resource is encrypted or not. This property is immutable, so we changed the API so that nobody can change this property ZQStack in advance. It's set only one time when the resource is created. And here you can see that the demo image as a demo volume is an unencrypted volume, so a secure stack is false. We repeat the step for a secure volume. We call it demo_stack. And here you can see that to tell the volume service that is an encrypted volume, we use this -- secure parameter. And the secure stack property is true in that case. We list all volumes which are in our cloud. And you see a difference between the secure and the unsecure volume. The unsecure volume is already available, but the secure one not, because we have to provide the keys. It's now in the provisionable state that tell us, okay, I'm waiting for your key. Please provide me the key, and then I can proceed with the creation process. And this is done with the OpenStack volume provision command, this new command we introduced. And you define the key for the volume with the -- secure parameter, and you define the key for the image decryption with a -- secure source parameter. And when we now list the volumes again, we will see that the state changed. Now the secure volume is starting to downloading the image and to copying the image. And when we list the image again, both volumes will be available and ready to use, for example, in a server. What we now do, similar to the image, we log into the volume service and try to read out information from that volume. Volumes are just block devices, and we can read out informations out of them. And this is what we try now. Here is the insecure volume. We will see a lot of information again, similar to the insecure image, the unencrypted image. And we will repeat that step with a encrypted volume, as you can see it here, and you will find no information. So it's encrypted. You cannot grab any, for example, SSH keys or any other useful information, personal data or business secrets or whatever. Now we create the server. It's the final step. First, again, the server which uses the unencrypted volume. It's a traditional OpenStack volume server, traditional OpenStack server create command based on a volume. And now we repeat this for the secure volume, for the encrypted volume. The command does not differ. But when we list the servers, we see the server who uses the unencrypted volume is already building, but the server who uses the encrypted volume is in a ready-to-spawn state. Though again, similar to the volume, the server is created, but the server is waiting for the key to attach the volume. And this is what we will provide in the second step in the OpenStack server spawn command. As you can see it here, we define the key for the volume. And when we now print or list the server again, we will see that both servers are active and ready to use. And at the final step, we will log in the secure server, in the server who uses the encrypted volume. And I will show you the SSH key, which is in there, just to let you know that there is a secret in it. But here we logged into the server, and we print out the SSH key. So there is a SSH key in the server, but you cannot read it from the volume or from the image. So just final remarks to our next steps. We focused on the encryption of the user data, the securing of the user data, and the key management. And our next step is to have a look at the three remaining parts. That means secure the access to the cloud, the separation of projects, and hardening and protection of the OpenStack infrastructure. What we also want to do is we want to provide a lifecycle management for the SQStack infrastructure. When you have a lot of keys and certificates, you need a possibility to reject a certificate or to replace the keys, and we want to provide a tool for that. And what we also want to do is we want to put our SQStack extension as much as possible to upstream so that everybody can use this extension to have a secure cloud, to operate a secure cloud. In case you have questions, do not hesitate to contact us. Here is the contact information from Matthias and also from mine, the email and also the telephone number. And we have also a website. This is on the next page, www.secostack.com. You can visit to get more information, to stay informed, to stay updated about new features and the progress of our work. And now I guess we have some time for questions.
Could you comment a little more about your upstreaming plans?
This is a very, very good question. It's our first OpenStack summit, and we got in contact with the responsible person, how to put something upstream, how is the workflows there, and we got a lot of information, and we will, how can I explain it? We will provide.
We have to figure out how to put things upstream, so bear with us.
But it's pretty much ready to upstream, you feel, at this point?
Some parts are ready, some parts are don't ready. So we don't want to put things upstream which aren't tested and documented very well. So from my point of view, we only give things upstream when we think it's ready, and it doesn't make sense to give things upstream which are not ready in our prospect.
Okay. Hi, I would like to ask you on what OpenStack release your patch is based actually?
Queens.
Okay.
It's Queens.
What you demonstrated works on LVM volumes. Would that work transparently on Ceph?
We did not try it yet.
Okay.
It's an open question if this works on other volume backends, but it's also a point we want to figure out.
Sorry, question. When decrypting the image and creating the volume, isn't there a point in time where the volume is not encrypted yet?
No.
How is that possible?
So if you provide the keys to only one volume service, and there each are several other services, is there a disadvantage to lose some of the HA features because you do have some many volume services because of HA in the control plane? And what will happen if the service, the volume service, which knows the key, will fail?
We didn't test it at the moment, live migration or any HA features. So we have to figure it out, to be honest.
Okay, thank you.
Yeah.
And do you use Barbican for certificate management?
Sorry, I didn't get it.
Do you use Barbican for certificate management?
Yes, we use Barbican for certificate management. Just for the certificate for the signature, for the image signature, but not for the certificates from the volume services or the OpenStack services.
Because they plan to deprecate that in the future releases.
Could be. But it does not influence our architecture.
Okay, thank you.
Thanks for the hint. Any further questions? Oh.
I'm sort of guessing that this will not work with the dashboard very easily without introducing a lot of
Not yet.
do you have any plans to try and do that? Or?
Yes.
Yeah.
But it's it's dashboard. It's command line is one thing, dashboard.
There are some, right.
Okay. Thank you.